Hello everyone, and welcome to Physical Science. We're in Unit 10, Section 2. Today we are going to talk about energy transfer. So how energy transfers from one object to another. We talked about how heat is a measure of the motion. So the hotter you are, the faster you're moving. And then the cooler you are, the slower you're moving. So it's like Miss Mitchell at the dance club. I'm super hot because I'm dancing real fast. And then like my husband is like the chill dude. He's just kind of swaying and he doesn't have much motion. So how does that energy transfer from one to another? So we need to make a table in our notes. We're going to title that table Types of Thermal Energy Transfer. So we're talking about heat and how heat transfers. Going to draw in a big old chart, and it's going to have 3 columns, and the categories are going to be type of energy or type of transfer, a description of what's happening, and examples. Okay, the first one is conduction. Conduction is when you actually touch something. So this says when energy is transferred between objects that are touching. I'm just going to write touching or contact. So if you were to leave your hand on a desk, when you lift your hand back up, you will notice that the desk is warmer because energy has transferred between your hand and that desk through touching or contact. Another example that's a little more extreme is a frying pan. Burning your tongue while you're eating. The energy, not the frying pan is not burning your tongue while you're eating. The frying pan is probably burning your hand. I hope you haven't stuck your tongue on a frying pan. But when you burn your tongue while you're eating, the energy, the heat, the thermal energy is transferring between the food and your tongue. So the energy is going from the food to your tongue. The second type is convection. Convection is when particles of a fluid or a gas are going to be swirling around and circulating. So right, fluid, gas, or liquid move by circulation. They circulate. So a convection oven where it will go up and then down, heat will circulate like this. If you've ever boiled water, you may have seen like those little lines of convection. You'll see like squiggly lines where heat is moving up and down in a circle. So our examples are convection oven or ceiling fan. The last type of thermal energy transfer is radiation. This is light waves. This is when light is, and waves are transferring it. So sunlight, a microwave, that light from a fire. So if you are not touching something that is burning, but you are holding your hands away from it, and you can actually get sunburnt from a fire. I've sat around a fire long enough to actually get burnt from not even being like touching the fire, but from radiation from the fire. Okay, so here's the examples. This is a guy holding a pot above a fire to boil some water. First of all, figure out some contraption so you don't have to hold it over the fire. That's kind of dumb. But if you were to do this, you're going to have all 3 types of energy transfer occurring. Your hand is touching this, the handle. The handle is going to be hot. So the heat is going to be transferring from the handle to your fingers by conduction, by touching. So conduction is just touching. When you're holding that pot of boiling water above the fire, the energy is going from the flames to the actual pot through radiation, because energy is radiating through waves. You're not physically touching the thing that is burning. It's the rays that are coming off of it that's heating it up. And then in the pot, you have convection going on, where hot, and if you think back to Earth and Environmental Science, they talk about hot goes up, cold goes down, because that's convection in the mantle. Same thing here, where hot will go up and then the cold will drop back down, and it creates this type of cycle, hot going up and cold going down. This is energy transfer through a cycle or convection. So there are some things that we can talk about when it comes to energy transfer in terms of speeding it up, making it happen faster, or slowing it down that we use. So conductors and insulators. And we're going to create two categories. So conductors are things like metal. Well, it's pretty much just metals. Lots of metals. Glass can be a conductor too, but mainly metals. When you see metal, I want you to think of conductor. That's why all cookware is pretty much made out of metal. Versus insulators. Insulators are things that do not allow heat energy or energy at all to transfer through. These would be things like plastic. They use plastic coatings around things that they don't want to transfer energy. Wires are wrapped in plastics or rubber. Rubber is a good insulator. Wood is a good insulator. Paper is actually a good insulator. So all these things are going to keep energy from transferring through. These are the things that you would wrap around something hot if you didn't want to touch it. When you use a hot mitt, you are using an insulator so that the energy doesn't go from the metal into your hand. You don't have a conduction going on so that the metal doesn't transfer the heat to your hand. All right, everyone. Thank you very much and have a wonderful day.